All right, good afternoon. What we are going to do today is we are going to see if the amplitude affects the wave speed. Now, for this, walk this through a little bit yesterday. I'll go through it one more time with you. You guys can follow along, do the first one yourselves, and then you can change the amplitude to a medium amplitude and a large amplitude and see if that impacts the wave speed. So, first and foremost, you want to enter into the wave intro simulation. Um, It looks like this. It's linked in the assignment. Press play, click on water. Okay, and for this, you can turn the water on by pressing the green button. If you want to hear the drops, that's fine. If not, hit the mute button. So we're going to turn the amplitude just like it has in the picture here down to a small value. Okay, and we're also going to take out the tape measure and the stopwatch. Now I'm just going to use the tape measure here as a reference point to time things, but we're going to count the number of waves that pass that point. In fact, we're going to do 6 of them, and we're going to record the time. Then we're going to calculate the frequency, and we're going to measure the wavelength. We're going to repeat this 3 times and find the average. So looking at this, I'm going to use the middle of the blue line. Ready, go. Oh, didn't work. Ready, set. 1, 2, 3, 4, 5, 6. Okay. So in 6 seconds, the number of waves that passed that point was 10.03 seconds. So what we're going to do here to figure out the frequency, remember, is the number of waves per 1 second. So this is going to be 6 divided by 10.03 seconds. And when we do this, 6 divided by 10.03, we get 0.6 hertz. So right in here, I'm going to write 0.6 Hz, and that is our frequency. Now I'm going to pause this then and measure the wavelength. So remember, the wavelength is going to be from crest to crest or trough to trough. So that means for this simulation, you're going from the center of the dark blue to the center of the dark blue. And here we get 2.6 centimeters as the first wavelength. So we're going to repeat this twice. I'm going to move this out. We'll hit play again. I'll reset the stopwatch, and I'll just use this as a reference here. Ready, set, go. 1, 2, 3, 4, 5, 6. Okay, so in 6 seconds we had 10.58. Sorry, in 6 waves we had 10.58 seconds. So if we make this calculation, this is 6 divided by 10.58, and we get 0.56 hertz. Okay, now I'm going to pause it again, measure the distance from center to center of the wave. So I'm going to line that up as good as possible. We get 2.8 centimeters. All right, we're going to do this then one more time. Again, I'm going to use this little cross here as a reference. I'll reset the stopwatch, play the simulation. Okay, ready, set, go. 1, 2, 3, 4, 5, 6. Oh, it was 10.06, and I accidentally hit it twice, so it's still 10.06. All right, so 10.06 seconds. Oh, 0.6, not. That was the first time I stopped. 0.6 seconds. We calculate that out. It's going to be 0.06 hertz using the same process I did over on the right. And then now time to pause this and measure the wavelength. So we're going to measure from crest to crest here. So it looks like approximately 2.5 centimeters. Okay, then we're going to do averages. So to find averages, right, I'll do averages of wavelength and averages of frequency. To find the average, it is 2.6 plus 2.8 plus 2.5, and then you divide that by 3. The top being 7.9 centimeters divided by 3 is going to be the average wavelength is 2.63 centimeters. So you guys want to just record this here. And then the average frequency, we'll do 0.6 plus 0.56 plus 0.6. We add those together, divide by 3. We get 0.59 hertz. So we're just going to put in the average over here, 0.59 hertz. Okay, you don't have to worry about those two boxes. You can just put 0.59 and 0.63 centimeters. Okay, now the last part here, find the average wave speed. So in red, I will make the calculation. We are going to do the wavelength times the frequency, which is going to be 2.63 times 0.59. And we end up getting an average wave speed of 1.5 meters per second. And we're just going to record this as the average wave speed. So this here is our answer for B. V equals 1.5 meters per second. So what you guys are going to do is you're going to change the amplitude. So the next round, you're going to change it to a medium-sized amplitude and then a large amplitude, and you're going to repeat this process.